Welcome back. We are doing homework solutions for Thermodynamics II at South Dakota School of Technology. We're doing homework 6, which is vapor-liquid equilibrium / Raoult law for adults / azeotropes. Okay, and so this is an azeotrope problem. The problem states, assuming 3 suffix Margulis model, that guy, is kosher, identify where the azeotrope should occur with A equaling this and B equaling this and saturation pressure equaling this and saturation pressure equaling this, okay, and P equaling this. So I know the A's and B's, and I know my saturation pressures, and I know my temperature. What I don't know in this case is I don't know where the azeotrope is. I don't know Xi, and I don't know PAZ. What I do know, and I should recognize right away, and I should write down, is that I do know that at an azeotrope, Yi at an azeotrope is equal to Xi at the azeotrope. And as such, Raoult's law for adults becomes P equals gamma I Pi sat, which is equal to gamma 1 P1 sat, which is equal to gamma 2 P2 sat. All right. I mean, I should write that down before I even think about anything, okay? All right, but I have that. Okay, well, I'm going to rearrange this, and I'm going to RT natural log both sides because I have RT natural log gamma 1 and gamma 2. What do I mean? Okay, so I have P2 sat over P1 sat equals gamma 1 over gamma 2. I want to RT natural log both sides so that I can use log rules. Okay, so I use log rules and I can just plug these equations in. Okay, and well, I know P2 set and I know P1 set and I know T and I know R. Well, you know what? I can just say that that's all a constant, okay? So this is all equal to K1, okay, or kappa 1, okay? And then let's plug in our things, and let's kind of distribute some of that math out. Okay, so we have bx2 squared plus 2ax1x2 squared minus bx1x2 squared minus everything there. So minus x1 squared, ax1 squared minus 2b, or not to be? No. X squared x2 plus 2a x1 squared x2. All right. Okay, so I mean, essentially, this is going to boil down to some algebra. Okay, but let's kind of feed along the algebra a little bit. Okay, so I'll help you out with the algebra a little bit. But the key step here is that recognizing that that equals and that results in this math, I separate it and I RT natural log both sides. Okay, that's the biggest step. Okay, everything else at this point is going to be essentially algebra. Now I have one equation and I have two unknowns. We'll get to that second equation in a sec. Let's kind of clean this up. But the other thing I don't know, see, I have two unknowns. I have pressure and I have three unknowns. Pressure, x1 and x2. But I know that x2 is equal to x1, and so I can, 1 minus x1, and so I can use that knowledge, and plug those kind of back in. Yeah, you know what? Let's leave that as is, because let's get our second equation out there. Okay. Now I'm going to leave this, and I'm going to leave this, I'm going to leave all these other things, but I am going to erase this one. Okay. And what I want to do is, instead of focusing on this, I want to focus on this. Well, not really this one. But I want to focus on the fact that P is equal to P1 sat gamma 1. Okay. And then I want to separate, and, you know, like I do here, I want to separate things in there too. Okay. I'm going to have two equations, two unknowns. Now this one might not be like, okay, do you really want to do the RT? I still want to do the RT natural log because that will make it easier to kind of plug A and B into each other, okay? Or rather, the x1s and the x2s and all that nonsense, okay? Because really, I know A and B, I could simplify this out and just get x1 equals. You know what? Let's do that. Why not? So let's ignore this for now. Okay. I mean, I've written it already, so I can erase that. Let's focus on this, because, yeah, I mean, I know K1, I know B, and I know A. Really, I just need to get all these, you know, x1s into x1 equals. Okay. So that's not too crazy. Well, not too crazy. Kappa 1 is equal to b minus 2bx1 plus bx1 squared. That's the x2 squared. Plus 2ax1 minus 4ax1 squared plus 2ax1 cubed. Okay. Minus b. Oh, wait. That should have a 2. Yep, that should be a 2. Okay. And so minus 2b x1 minus 4b x1 squared plus 2b x1 cubed minus ax1 squared minus 2 bx1 squared plus 2bx1 cubed for that guy, and same thing with that guy, plus 2ax1 squared minus 2ax1 cubed. Yikes. That guy, that guy, that guy, that guy, that guy, and that guy. So everything's accounted for. Alright. So let's start combining like terms here. Because, I mean, this thing's just, you know, and really, well, more than anything, not so much like terms, but let's start canceling things out that I can obviously see. Okay, so I've got some x1 cubes in here, okay. Okay. So here's a minus 2ax1 cubed, and that cancels out with that ax1 cubed. I want to say that this one should cancel out with this one. But of course I erased my stupid answer, so it's really hard to tell. Let's see here. There was, so I had a minus, it came from the minus bx1 x2 squared. That would equal minus bx1 plus 2bx1 squared minus bx1 cubed. Oh, 2, because everything would be a 2 because of this 2. So that should be a minus 4. Because there's a 2, yeah, because there's all the A stuff and there's that one. It should be minus 2 plus 4 minus this one. Yeah. Yeah. And there's my minus ax1 squared. So yeah, so that's minus 2 plus 4 minus, good, okay. And now those simplify out correctly. Okie dokie. Yes, and then I have bx1 squared, a minus, because it was a minus this whole thing, plus, okay, and so I'm on the right track. Okay, good, 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 good. Okay, so those go away, all right. And so, let's see here, I have, let's do my, x1. So I have a b, boom, 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 boom. Okay, I don't have anything else that is just like non-x1. Okay, so I have a b. Let's do my x1s. Plus x1. So I've got a minus 2b. I've got a plus 2a. Minus another 2b. Okay, plus x1 squared, all right. So I've got a b minus 4a plus 4b minus a minus 2b plus 2a. All right. Yikes. So when I'm all said and done, this is equal to b plus x1 times 2a minus 4b plus x1 squared minus b 3b, yep, minus 3a. Yep. Alright, and that's a lot cleaner, but the problem here, so we have a problem here. I can't solve that straight up analytically. I have to use Mr. Quadratic equation. Okay, and so what I have is I have 0 equals 3b minus 3a x1 squared plus 2a minus 4b x1 plus b minus kappa 1. Okay, so there's my a, there's my b, and there's my c in terms of quadratic equation. I solve it, plug it in, whichever one makes sense. One is probably going to be negative and one's going to be probably positive. Or at least one is going to be between 0 and 1, and the other one is not. The one that's between 0 and 1 is my realistic answer. Okay, and so I'm just going to plug in numbers into quadratic equation and get my x1. Alright, that was fun. Okay, but that just gives me an x1. That's fine, because remember, I can go back to the original p, so I know where x1 is now, which means I also know where x2 is. And p is equal to gamma 1 p1 sat, or p azeotrope rather. And so this is equal to, well, this nonsense exponential. So p1 sat, which I do know, exponential of, so I'm going to say b prime is equal to b over rt, and I'm going to say a prime is equal to a over rt. And so this is going to equal, well, yeah. So x2 squared b prime plus 2 A prime minus B prime x1. And again, those are all azeotropes. So that's an azeotrope, that's an azeotrope. The one that I just solved for, basically. Okay, and I know A prime and B prime, and I can just plug those in and be hunky-dory. So, and then I know P1 sat, so I can just literally plug in and find out where the azeotrope pressure is.